Hi everyone, we are Team Avengers and today we'd like to explain our project, Real-Time Fraud Detection for Digital E-Wallets. So here will be joining us will be my teammate Kedrick Selvenasan and me, Jeevanish Kunalan. So the case study we have chosen was Malaysia's digital wallet fraud crisis. So the problem statement is there are about 2.77 billion lost to scams in 2025 alone. And among that, only 6% recovery rate has happened. So the reason why we chose this, first of all, there's like a policy made by BNM where all e-wallets need to have some kind of fraud detection to avoid this problem. And we also have a lot of data available, such as the PaySim data set or any other data set that is released by banks and any financial institutions. And obviously, there's going to be a lot of local impacts too if we can solve this problem of fraud detection. Because Malaysia digital payment volume have reached about 417 billion by 2028 alone. So what's our solution? So the solution we have came up with is a hybrid architecture where we use two AI models, which is FGBoost for fast decisions and Finbird, which is encoder LLM for contextual intelligence. So since we use PaySim data set, one of the things we have done is we engineered few features. So what are the features? First is temporal, where we took the date and time and came up with how of the day is night or is weekend or anything. And behavioral data features such as how much transaction they have made in the past 7 days or how many transactions they have made. And obviously entity flags are the merchant or the customers. And after we got the results from the XGBoost, we will go for the NLP layer. And the NLP layer will analyze unstructured data such as the beneficiary, alias, chat log, or even device metadata. So how the data will flow is we will give the data such as all this information about the transaction to the XGBoost, but only the structured data will be analyzed by the XGBoost. And if the XGBoost give more than 80% probabilities, then it will get blocked instantly. Or even if 20% lower, then means the transaction will be approved immediately. But if it's in the middle, then the NLP layer will come in and make sure that it can analyze the unstructured data so we can get a better analysis of the transaction. This will make sure that we don't have too much latency since we don't have to analyze everything with our Finbird model. And since Finbird model is very heavy, we don't use it for everything. So let's look at the front end demo. So this is what a usual digital e-wallet will look like. So let's say someone wants to send money, right? So if they want to send the money, they have to give the recipient ID, their name, how much amount, and the type of transfer they will give. So let's look at some example. So once you put amount and their name, something like mom, and then some amount, you have to confirm and send. And this is our simulation config, which means this is the backend data that will be sent to our API. So since we are mocking it, I am creating all this data by myself. So let's see how the API will give result. So let's say I have created this mock data and then we run this fraud detection and we're verifying the transfer and the transfer is successful. And then if we look at the dashboard, you can see that first the XGBoost have analyzed that or gave a prediction that is 58.8% fraud. So since it's in the middle, Finbird model will come in and do another analysis. And since it's only 20%, it's approved. Let's look at another example. Now it's blocked. And if it's blocked, the user have to contact the numbers or the nearest branch to make the transfer possible. And if you go to the dashboard, the admin can see that it's blocked because the XGBoosts have detected that it is 99% is fraud. And let's do another example, and it's successful. And if you go to dashboard, we can see that the XGBoosts have detected that it's a very low in fraud probability. So this is how a usual digital e-wallet using our API will work. So what's the technology stack we have used? Obviously, two AI models, XGBoost and Finbird. XGBoost is used because it's kind of like the king of structured data that is widely used in financial institutions. And Finbird is a bird model, or the baseline model is a bird, and it's pre-trained on finance text, so we don't have to fine-tune it with finance text. We can just fine-tune it to detect these frauds. And PaySim data set, we have used those the data set because most of the data set we could find is hidden, like the columns are hidden because it was released by the banks, and then they don't want information about their customers to be leaked. But PaySim is not like that. We could see the columns name. And Sharp is the feature that we use to explain what features that XGBoost use primarily to come with the prediction. And Fast API is the backend framework we use to deploy. And Railway is the cloud deployment service that we use to obviously deploy our API. And Lovable UI is the software we use to create our front end.
Okay, so let's move on to the market segment. So this is how I show you that this is the market opportunity we are addressing. So let's move on with the first tier, where the first tier is our primary targets, where we have major Malaysian e-wallet operators like Touch and Go, Boost, and GrabPay. So these are regulated e-money issuers which face high fraud and high regulatory scrutiny from BNM's 2025 mandate. The second tier is where fintech startups and neobanks, where early stage players who lack in-house machine learning expertise and need a low friction API solution. Where the third tier is about e-commerce payments processors like Shopee, Lazada, and TikTok Shop. They handle massive transaction volumes and are increasingly exposed to seller scams and also QR code fraud. And the fourth tier is the SME banking divisions like Mbank, CIMB, and Maybank. These teams already run transaction monitoring. Like for example, Mbank alone prevented 2.7 million in fraud, and they're looking to reduce fraud losses further. Okay, so this is our proposed business model where we provide API as a service. So we've built this as a REST API that any digital wallet, fintech app, or payment platform can integrate with a single HTTP call. So let's go on to the customer segments where we serve e-wallets like Touch and Go and Boost, fintech startups, BNPL platforms, and e-commerce payment gateways. Our value proposition is we have real-time fraud detection with a sub 3 millisecond latency, hybrid XGBoost plus Finbert NLP contextual analysis, which no competitor offers at this price point, and we have BNM compliant outputs with plug and play integration. Our channels is we reach customers through our developer portal, fintech accelerators, the BNM's regulatory sandbox, and cloud marketplaces. How do we have customer relationships? Is we start with self-service through our free developer tier and then provide account management for growth clients and dedicated SLA support for enterprise. Our revenue streams, we have four sources of revenue, which is pay per transaction. Second is monthly subscriptions, and third is enterprise contracts with annual SLAs, and finally compliance dashboard subscriptions. So our key resources is our train XGBoost model and also Finbert NLP pipeline with fast API backend, as explained by Jiva earlier. So the key activities, which is model training and updates, API unique monitoring, fraud pattern detection, customer onboarding, and compliance documentation. So this is our competitor analysis. So I will just go through briefly. Like for example, PayNet's Finance GPT. This is the government's national fraud infrastructure currently in development for 2026 rollout. But they have an infrastructure layer where post-transaction fundraising. So this is not directly a competitor, but it's a complement to our project. And another one I would like to highlight is FlagRide, which is a closest competitive tier. They are actively targeting Malaysian fintechs with AML compliance tools, but FlagRide is an AML workflow platform focused on case management and suspicious transaction reporting. They are not raw fraud scoring API like we are. Our competitive advantages is we are API first, where we are a single HTTP call. We don't need months of deployment and infrastructure integration. Our sharp extendability is built in and not add-on. And our sub 3 millisecond latency beats enterprise competitors who range from 5 to 50 milliseconds. Okay, so this is briefly our model performance, but I want to highlight why AUPRC, which is the area under precision recall curve, matters most. So this matters most because in context, this reflects real world performance better than the ROC AUC normal precision recall and also F1 score. Okay, so this is our planned feature roadmap. So the first one is to improve a better optimized NLP model, like maybe a mock tiny bird or distill bird, that achieve 10 to 20 millisecond CPU inference latency. The second one is integrate Sharp in API responses. As of now, our Sharp responses are offline, so we are planning to integrate Sharp explanations directly into API responses. And the third one is using real-world unstructured data. As we have explained earlier, PaySim is more of a simulated data, so we are planning to use real-world unstructured data to further improve the accuracy of this model. And the next one is dynamic threshold tuning. So as of now, we're using the thresholds which are fixed at 0.2 and 0.8. So we are planning to make adaptive tuning based on the fraud rate trends, transaction velocity, and also the user behavioral profiles. And in midterm feature roadmaps, we are planning to have graph neural networks. So this research shows that GNN plus XGBoost hybrids achieve better F1 scores on financial fraud datasets. And then we're planning to have a financial foundation model following the feature space NPPR approach, followed by the next one, which is real-time graph processing, which we integrate streaming updates via Kafka to detect fraud patterns evolving in real time across transaction network. And finally, a full BNM compliance module, which auto-generating suspicious transaction reports, sanctions screening against BNM's list, and customer risk scoring. Okay, next. Okay, that's all from us. We've attached our web app link, our GitHub link, and also our email if you would like to contact us. Thank you.